Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us we have Reagan. Reagan, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So, what grade are you in and what school do you go to?
I am in 6th grade and I go to Buena Vista Elementary.
So you're a Bulldog. Mm-hmm. Have you been a Bulldog for a long time?
Yes, I've been it my entire life.
Well, not your
Well,
entire
yeah, for,
life, but for your school life.
Yeah.
All right, I know
destined
you
to be
mean,
a
right?
Bulldog.
So since kindergarten, you've been at Buena Vista.
Yeah.
So next year is going to be a big year for you.
Mm-hmm.
Are you looking forward to anything at junior high school?
For band and chorus.
Oh, good. Okay, so are you involved in that right now?
I'm in chorus, yeah.
Okay. So do you have an instrument that you're thinking about for band?
I want to do the clarinet.
Okay. How is 6th grade going so far?
Really good.
Really good?
Mm-hmm.
Is there anything that you think you're going to miss the most from Buena Vista because you've been there for 7 years?
Probably all the teachers.
All the teachers you've had, right? Well, you
Yeah.
spend a lot of time with them, right? Because you're in
Yeah.
the classroom with them every day. You don't change like in high school and junior high school, right?
Yeah.
So you spend a lot of time with those people. So it's nice to see that you're going to miss them because you spend, like I said, a lot of time with them.
Mm-hmm.
All right. What kinds of things are you doing in your math class right now?
We're dividing fractions.
And how are you with dividing fractions?
They're pretty easy.
They're pretty easy? Good. So you got the hang of that. So we're going to give you something else to work on today since dividing fractions is pretty easy for you.
Okay.
So I also understand that you are a swimmer.
Yes.
And you're a pretty good swimmer.
Yeah.
And how long have you been swimming?
I've started swimming when I was 6 months
So
old.
this is the all your life
That's
kind of thing,
Yeah.
right? So you've been swimming all of your life. And you started swimming at 6 months. And how old are you now? You must be like
I'm
11.
11.
All right, so you're 11 years old. And do you have a favorite of, because I mean, you're pretty into swimming. It's not like you're just a swimmer,
Yeah.
a casual swimmer. You compete a lot, right?
Yes.
So do you have a favorite event or one that you like more than others?
One that I really like right now is the 200 fly.
Okay. And are there other events you compete in, or is that the one you do?
I do many others.
Okay, but you like the 200 fly the best.
Yes.
And for other kids out there that might be swimming also, you do pretty well at that, kind of like what's your time on that? And
I think
I
it's
don't
like
throw you out.
2 minutes something. 2
Okay.
minutes, 30 seconds something.
And that's a pretty good time, right? Because if you're competing against other people, you do pretty well, right?
Mm-hmm.
All right, good. And you've got pretty big meets coming up, correct?
Yes.
Like, how big are these? Like this, like these are like state meets and stuff, right?
Kind of, yeah. In February, I have a really big meet.
Okay. Well, good. And you train for that a lot?
Yeah.
Do you do this like on the weekends, every day?
I do it 6 out of 7 days a week.
6 out of 7 days a week, so you're a pretty serious swimmer.
Yeah.
All right, well, maybe sometime we'll get you out to the pool, you can race Scott, and we'll see how everybody does. Anyway, we'll get you busy with a little bit of math later on, but first, let's take a look at today's Math in the News. All right, well, today's Math in the News has to do with another sport. Have you ever heard of freestyle football?
No.
You haven't? Have you ever heard of
I don't know if
freestyle
I have.
football?
No.
I didn't either, to be quite honest. Freestyle football. When I think of football, I think of American football.
Right.
I know most of the world thinks of football as what we would call soccer.
Right.
But we do have a short video to show you of some freestyle football right here.
Oh.
So Reagan, you think you can do anything like that?
No.
That
my
takes some
goodness.
practice right there. So they're
Yeah.
using a soccer ball, right? And this is freestyle football. So it's kind of like dancing, I guess, you know, using a football, doing a lot of athletic moves, using some creativity to get the most points. And we can see an example right there of a pretty good
That's
football
pretty amazing, yeah.
artist right there. And so that got me because the championships just occurred for 2022. And so that was on the news, and I'm like, oh, that was pretty cool like that. And I'm like, soccer ball. That is a truncated icosahedron. Did you know that? No, you did not
do
know
now.
that. All right, well, that is a truncated icosahedron. So what we're going to do is we're going to take a look at, I think we're going to take a look, if I can get the screen to move. Let's have it go like this. All right, we'll go here. We'll start with this one. So right here, this is a truncated icosahedron. Does that look like a soccer ball to you?
Yeah.
Yeah, it does, right? Because you've got some hexagons and you've got some pentagons, right? So there's 20 of one, 12 of the other, and that's how you make up a truncated icosahedron. So have you ever seen any of these other solids? They're called the Archimedean solids.
I don't. think
Probably
so.
not. I mean, this is probably the only one you would pretty much be associated with.
Yeah.
But when you take geometry in high school, you're probably going to see some more of these things, all right? And the reason I was like, all right, well, that's another way we can get into mathematics with the soccer ball is to see exactly what it is and what it's made up of. So if you took it all apart and you laid it out, it would be what's called a net. Have you ever heard of that term before in mathematics, a net?
No, I have not.
So here's what it is. So this is a soccer ball, a truncated icosahedron, right? So we've got the hexagons and the pentagons. So which one has more, the hexagons or the pentagons, do you think?
The hexagon.
The hexagons, right? So there are 20 of those and 12 pentagons that make it up. But if you unfold it all, like if you took an actual soccer ball and took all the stitching out of it, right, so that you could lay it down, that's what it would look like as a net. Does that make sense now? All right. So here are some other solids that you're probably more familiar with. All right. Have you ever heard of a hexahedron?
I've never heard of it. No.
But you've seen one of those.
Yeah.
What is
I've
that?
seen a cube.
Oh, right. Okay, so it's a cube. Okay, so it's just another name for it. All right. Do you know what this is? Like, what would you call that if you saw that?
Triangle or 3D, like.
A triangular pyramid,
Yeah.
right? Okay, so it's just a pyramid. And then you get into some of the more complicated ones right there. But you later on are going to make some of these things, and we're going to see if you can make some by laying them out, putting the pieces together, making a net, and then folding it up to see if it actually works to what you think it's going to be. Sound good?
Okay.
All right, that's a deal. You can do that later on?
Yeah.
All right, good. That is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. And today, I believe it is October 26th. Is that correct, Mac? October 26th. This is the final day that you can call in to do the math. And if we do one of your math problems on air, you will automatically receive a pass to go to Autumn Nights, the brand new light show happening out at COM. So a lot of people are familiar with Holiday Lights at COM, where now you drive through that experience, and that will be coming up once again this year. But the Colonel, Steve Sanders, with the Kern County Superintendent of Schools, was here a couple of weeks ago to talk to us about Autumn Nights, and we had some footage of that. Excellent, and there it is, some right there. So this is some footage of what you can expect if you go out to Autumn Nights. A brand new show that they have out at COM. And this is one where if you'd like walking through the grounds at COM, this is what you can do now. And it ends on October 30th, this Sunday. That's why today is the final day that you can call in. And this happens Thursday, Friday, Saturday, and Sunday between the hours of 6 and 9. So that is Autumn Nights. Hopefully you and your family may have an opportunity to go out and enjoy that before Halloween on Monday night. And if you'd like to go for free, all you have to do is give us a call and we can set you up with a pass to go enjoy that right there. Not a bad deal, is it? You know how to do percents and things?
Yeah.
All right, good. So we're going to make you do a little bit about that. But first, do the math. We often have opportunities to go out and about town, and today we're going to meet somebody very special, Diane, and learn a little bit more about biplanes.
I'm Diane Barney. Thank you for joining me here at Bakersfield Meadows Field. I got some cool stuff to show you. So behind me and to my right and my left are three very different biplanes. This is the one I flew in today. This is a Boeing Stearman. It is actually a World War II primary trainer. Believe it or not, you look at it, it's big, it's complicated, but an 18-year-old kid who is getting trained, this would be the very first aircraft that he would get behind the controls of. What's special about biplanes in general, right? So you've got a whole nother set of wings up at the top here. It's actually because it took us a long time to figure out how to make structures that are strong enough to hold up an airplane, right? So you've got a lot of force going from the wings to the fuselage. So at like your interface right here, you've got a lot of force going in there. If all you've got is wood and just some rudimentary metal, well, now you need more attachment points. So in addition to the wing root here that you'd see on a normal airplane, you have all these other struts, you have these flying wires, which are actually very, very strong, and then struts out here too. So you have all these other devices to connect the lift that's lifting up the airplane to the rest of the aircraft. And having been a primary trainer for World War II, you probably thought, oh my, how old is this? It's a 1942. Now, how much of it is original from 1942 is debatable, right? You keep up with the maintenance on these things so that you can keep them flying. But it is fabric in many places here, so it squishes in if you push on it. But we do have aluminum, and the structure under the fuselage, underneath the fabric, is metal. But our wing spars in this aircraft, they're made out of wood. Here, come around to the side and let me show you what it looks like in the aircraft. So it's not a cargo aircraft, so there's not a ton of room inside of it. You notice there's two different cockpits here. And you might think, oh, as the pilot, I want to sit up front. No, no, the pilot sits in the back. This is the person who's the pilot in command of the flight, and your student sits up front. So in the back, you actually have much better visibility, because you think, oh man, I really need to see forward. Well, that really helps. It makes it a lot easier if you're taking off and landing and in flight in general, but you don't strictly need it. So this aircraft, your perspective, when you're sitting in here, you see how high that nose is? Unless you're very, very tall, you're probably not going to see forward very well anyway. So when you're sitting in the back, you can see to the sides and down much better, and of course up as well, which is significant when you're in formation and you're looking out for other aircraft in the traffic pattern. Getting up in the airplane, right? There's no steps. You have to do a little bit of yoga to get in. And then you hop in. So you have more controls back here than you have up the front. So it does fly with a stick like a fighter. Still a trainer, but it's a lot of fun. And you've got your throttles, your mixture, and your propeller over on your left side, so right underneath my left hand. We've got some electrical switches. This aircraft has an electrical system, not originally, but it does now. So that's been installed after the fact. And you've got a radio and a transponder way down here. So as you can see, that's not original. That's not very convenient when you're flying around and you need to go heads down and you change a frequency. And then you just have a very basic set of instruments up here. So you notice there's not really a lot by way of navigation. So I've got a compass, but other than that, you're just flying around day VFR. You look at where the roads are, you see where the forests are, wind farms, rivers, and whatever else you can follow. Most aircraft that are going to be trainers are going to have engines that are, maybe 100, 150 horsepower or so. This one though, because this aircraft is so much larger at 3,000 pounds, it has a 300 horsepower engine. But this engine is still a bit oversized for what you'd expect for 300 horsepower. You notice 9 cylinders, and it's configured in what's called a radial. So it makes a fantastic noise. And that has been the Boeing Stearman, and shortly we'll tell you a little bit more about another impressive biplane that's even bigger than this one, an AN-2. Back to you, Mike.
All right, thanks for that, Diane. Great work out there, and nice to have our aviation correspondent joining us now on Do the Math with Diane right there. Just amazing. I mean, you know that we have done a ton of things with aviation here on Do the Math over many, many years, and it just fascinates me, all of the different aspects of aviation and all of the math and the science in it and just everything about aviation.
Yeah, yeah, pretty amazing.
So, would you ever do any wing walking on a...
Oh, I don't know. I have to have about 7 different tethers to the wing, I think.
At least,
Yeah.
right? On each leg. All right. So in studio we have Reagan. Reagan is a 6th grade student from Buena Vista Elementary, and you have some homework that's kind of a creative, different type of homework assignment. So explain to Scott what you have and what you need to do now.
So I have a 10 by 10 square. And
Okay, when you say 10 by 10, what kind of
inches.
units are inches? Okay, we're
Yeah.
talking about inches. Good. Good to know.
So I'm going to cut it up into different like squares
Mm-hmm.
and rectangles, and I'm going to create like art on it.
Gotcha. And they can be different sizes?
Yes.
That's okay? So they don't have to be any specific size. So the
Yeah.
hard part probably is going to be drawing the first one, right? How big do you want that first one to be? That's kind of what the question.
Yeah.
Because it doesn't sound like there's a lot more parameters in this kind of problem. And it's interesting when you give math students a problem that doesn't have a lot of parameters, sometimes they will struggle more than the ones that has a lot of rules because they don't know where to start. But I think you've been thinking about this for a while. Where do you think you might start with this?
Probably like a rectangle in the corner.
Okay, and how big do you think you want that rectangle to be?
4 by 3.
Okay, that's a good idea to try to keep it even number of inches, and then things will kind of work out a little bit nicer. This will still be rectangles and squares no matter what happens.
Yeah.
Some of them might be a little bit smaller or bigger. Some of them might be some funky numbers on there, but if you can keep them even numbers, that might work out great. So a 4 by 3. Okay, so go ahead. You're gonna use this as your straight edge, right?
Yeah.
And you got your pencil, just in case. We always like pencils because they have erasers on them too.
There we go.
And when you draw that, we're gonna go, what are you gonna measure first, the 4 or the 3?
The 3.
Okay.
So now So there we go.
Okay, so, and when you do that, maybe one thing you could do is, let's measure out here on the side of the square,
Yeah.
okay? And then just put a little mark there, because I saw how you turned it. It's a really good way to do it, but what if someone bumped your arm like that, right? Then all of a
Yeah.
sudden, there goes your measurement, and then it's kind of like, oh
There we
man,
go.
where do I start? Yeah,
Yeah.
now you know where to go. That's
Okay,
good.
so-
So this is what, 4 or 3?
That's 3 inches.
Gotcha. Maybe you want to put a little 3 there, just in light pencil, and we can
Okay.
mark it down later, or erase it later if you need to, just so you know how long it is.
Yeah.
And given that this 3, how much do you have left, by the way?
I have 7
Gotcha.
inches.
So that's always good to know too.
Yes.
Okay, and where are you going from there?
I'm going down to the 4-inch mark.
Gotcha. Now when you draw this line, let's be real careful because you don't want that line going all crazy crooked, right? And you
Yeah.
don't want it going down like a triangle.
Yeah.
So do your best to see if you can make it as even as possible with this one here, right? What we would call parallel to that line. And you're going to go out to 4?
Yep.
Good deal. Like I said, hooray for erasers, right? We like that part. Let me hold that part there for you so it doesn't move. There you go. See if you can get it all the way out there to 4. Good.
There we go.
Now how long should this side be?
3 inches.
If it is longer than 3 inches, what can you tell me about the line that you just drew?
It was off.
Yeah, if it's
was
shorter
crooked.
than 3 inches,
That
it'd be a little
means-
bit in like this,
yeah.
right? None of that's that big a deal. It doesn't need to be super exact, but we can go ahead and measure that now so you can finish your rectangle and let's see how close you were. Ooh, pretty close. A
Yeah.
little tiny bit off, but we're going to call that a rectangle today.
Okay.
Today it's a rectangle.
Today it's a rectangle, that's right, just a little bit off. When you make your next one, I'll maybe show you a little hint about how you can make sure that they're a little bit more close to being an exact measurement. Good for you. Nice job. So there's one. Now, next shape, I'm going to make it bigger or smaller?
Smaller.
Okay, and where do you want to put it? And what size do you think you might want to make it?
I want to do it 1 inch right here.
Are you going to do a small one? All right. So let's again go at the edge there. There you go. You do your 1 inch. There you go. And you can measure 1 inch on this side too, unless or do you want to go further?
I'm gonna go further than 1 inch.
How are you gonna go? How long are you gonna go on that side?
I think 5 inches.
Are you gonna go 5? All right, good deal. Now when you do this, let's see if we can do this part here. Why don't you go ahead and measure out 5 from here to there and just put a little dot down there at 5. Good. Now if this is 4, or sorry, this is 3, right?
Yeah.
And you added 1 more to it, how long should it be from the bottom here to where you made that dot?
4 inches.
Can you measure that out real quick and make sure it's 4? And if it's not, we can adjust it, right? So what do you think? It's awful close. Where should it be?
It should be
A little bit closer, right? So now you can make your dot still at 4 inches, but in a little bit tighter. So now you have a line that's parallel to this one, right?
There we go.
So now you can connect this dot and the new dot that you've just drawn, and you'll be parallel to the bottom.
Okay.
And I know you're looking forward to some constructions in geometry, because it's exactly what you do when you first get to geometry. You get to draw pictures, but they have to be exact pictures. All right, once you get it all lined up, I'll hold this side for you so it doesn't move. And you can draw that line. Yeah, either direction.
There we go.
Good, there you go. Now to make it a full rectangle, what else do you have to do? You
have
gotta
to
fix
put-
it up a little bit, huh?
Yeah.
Yep. How far down are you gonna go?
I have to go 1 inch.
You wanna mark off that 1 inch? Good. Now if this is 4, and you know that that side is 5, you already made that one, how far should this little one be?
1 inch.
Right, so can you measure that out and see if you're straight again? Because again, it should be pretty darn close. And if it's not, where is your dot?
It's right there.
Gotcha. So what do you think we should do? Maybe move that dot out just a little tiny bit?
Yeah.
Yeah. And when you do that, then you should have 1 inch on each side.
There we go.
Good for you. Now you can connect the dots, right? And we all learned that. People always wonder why we did connect the dots when you were in kindergarten. Well, this is it, right? It kind of all comes back in geometry. That's it. Looking good so far. Yep, 2 rectangles. What's next? More creativity. Gonna make a little 1/2 inch by 1/2 inch? No, maybe not so much. Let's stick to the whole numbers, right?
Yeah.
Okay.
So maybe a 6 by 3.
Whoa, all right, that sounds good. And you're gonna make that over here in this area? Or
right
up there?
here.
Totally
here.
up to you. How much do you have left here again?
I have 6 inches.
Right, because you had 3 and 1, and you know it's 10, so we have 6 inches left, so that's good. And you wanna go 3?
Yep.
Okay. So you can mark it off there. Good, there you go. Just like that. I'm gonna measure up 3 on this one too, and then you can connect the dots from here to here. Good job. Where's your 3 there? Just make that dot there. Did you make a dot?
No, I have not yet.
Okay. I'll help you hold it. Make a dot there at 3. There it is right there. Good. And you can connect the dots. Now that one might be, is that longer than your protractor? Oh, you barely made it. Barely made it. Good job. That's going to take that whole section over there. I'll hold this part for you. Good. Now, of course, it depends on how fast you want to get done with this, right? You can make
Yeah.
bigger ones and be done really quickly.
Yeah.
You can make really small ones and be here all day. Totally up to you. And so you're going to have some creativity ahead of you as well. And when you get done, it sounds like you're going to do a little bit of creativity with some colors
Yes.
and some lines. And who knows, maybe fill those boxes in, compare some areas, compare some perimeters. There's so much math to be done with a blank slate that's 10 by 10. Good
Right, I was
start.
going to say, the thing that you guys have done is you've done an excellent job so far, because you want to take your time with it, and you want to make sure what you're making is correct the first time, because otherwise you get the whole thing filled up and you're like, everything is off, and now I got to
Everything's
start
off.
all over again.
Yeah.
And you can see it takes a little bit of time to do it correctly.
Yeah.
All right, so nice start, and we're going to have you guys keep working on that. But right now, we do have another opportunity to head back out to Meadows Field and visit with Diane and learn a little bit more about the biplanes.
Thank you, Mike. And welcome back to Bakersfield. I am joined by my friend Todd, who is the founder of the Golden Age of Flight Museum, and he's brought a very special piece of that museum out to show us today. What is this, Todd?
This is an Antonov AN-2 biplane. It was built in 1977 in Poland. This one, when it was new, was an airliner for Aeroflot Airlines. Afterwards, it became a crop duster.
So like a big old tractor then.
It's a big flying tractor.
That's just too cool. Could you tell us about the engine on it?
Yes, it's a 1,100 horsepower radial engine. It's a 1,820 cubic inch, burns about 60 gallons an hour. So it's not the most efficient airplane, but it'll carry anything you put in it. So we cruise about 100 miles an hour.
Wow, 100 miles an hour, that's all
Yep.
you get out of this. So that much
much
more
more.
power than the Stearman, and we cruise at almost exactly the same speed. I think the Stearman's just a little bit faster than this.
But the benefit of having two wings is you can lift so much more weight. This big scoop on the bottom here is the oil cooler. Everybody thinks it's the air intake.
And so that's where the oil from the engine circulates through
It circulates through a cooler there to keep the engine cool. I named it the Fat Cat. We've got the Diane cat on the side up there.
So what about your wings? Are they like the Stearman wings at all?
They are. They're all aluminum, covered in fabric.
So
and
it's so not wood spars this time.
No.
Aluminum
No, this is all
spars
metal.
this time.
The construction technique is very similar though, but the newer airplanes, they went all aluminum instead of the wood on the inside. But it still has the bracing wires to hold everything together, so it's rigid.
Could you tell me about the part of the wing that's hanging down? I can see a lot of sunlight through it. Is that normal?
Oh, so on the flaps and the ailerons on this airplane, as you start to fly slower, there's more pressure on the bottom of the wing, and it pushes through that gap there and flows over the top of that flight control surface to increase the lift. And it helps the slow speed performance. And that's what this airplane was really made for, short runways, flying very slow, carrying a lot of weight. So the air will flow out here and flow along the surface, which gives you more lift. Without these, as the air flows over the top of the wing, as you start raising the nose up, it starts to swirl around and the gap blows air through and helps it fly better.
That's really cool.
That's the very technical description.
You could haul a lot of stuff in this. How much can it carry?
You can. It'll carry about 4,000 pounds. And the door actually has another bigger door that's part of the small door. This whole thing opens up and you can put whatever you need.
Well, can you show me the controls on the inside?
Let's climb on in.
Cool. My goodness, Todd, there is a lot more going on in this cockpit than there was in the Stearman. Do you have the same controls in here as the Stearman?
We have all the same controls and a couple more. So on this airplane, since we have one cockpit with two seats side by side, most everything is duplicated on the pilot side to the co-pilot side. If you fly with two pilots, they have their own set of instruments over there. This airplane was built and designed so that you could fly through clouds. So it has a couple extra instruments so that we can tell if we're right side up or upside down in a cloud. But as far as flight controls, it's all the same. All the engine controls, we have the same as you have in the Stearman.
But it's not a stick like the Stearman.
But it's not. It's got a regular control wheel like an airliner. And since the airplane is bigger, it has some electric actuators to run some of the systems where the Stearman has just manual levers.
So it's got so more than just mechanical systems in it. Does it have, well, we can see an electrical system,
Yeah,
like
it has
Stearman has
the,
one too, but then there's also, is there hydraulic?
The electric trim systems. There's no hydraulic systems, but this has air brakes instead of hydraulic brakes.
Like a tractor trailer?
Like a tractor trailer.
Really?
Yep, we've got a little handle here on the control wheel that you squeeze, and that puts air pressure to the brake discs to slow the airplane down.
So this really is just a big truck of a biplane, isn't it?
And it was really designed for operating in the middle of nowhere and people that didn't have common tools to work on it. So it's really easy to fix and repair.
Well, Todd, thank you so much for sharing your AN2 with us today.
Oh, thank you.
So when we come back, you'll get to see a modern high-performance sports car of a biplane. Off to you, Mike.
All right, thanks for that, Diane. Those things are wicked cool. I can tell you that right now because I've never been in one on my own because I'm not a pilot. But those things can scoot through the air. I'll tell you that a whole
Like the Red
different
Baron.
monkey right there. Indeed, it is. Reagan is still working on her project right now, and it looks as though you are a little more than halfway finished with that.
Yeah.
All right. Well, you know what? As soon as you finish that line, I'm going to have you head over to the board and work with Scott, because what I want you to do is work on some percents right now. And I would like you to give me a 2-digit number anywhere between 11 and 88.
19.
19. So I want you to find, Scott, pick another number, 2-digit number.
How about 27?
All right, indeed. So put 27 on the right of that.
Okay.
So I want you to find 19% of 27.
Wow.
So Reagan, discuss with Scott how you'd like to
So-
do it, and if you're a little stuck, he's right there to help you out.
I'm doing 27 times 0.19
Gotcha. Where did that come from? Tell me a little
because
bit about that.
you transform 19 into 0.19 because 19 is a decimal.
Okay, so you can make it into a decimal. There you
Yeah.
go. So what we have here really is like an English question, right? What is 19% of 27? You want to change it into math, and that's what you've done so far. So we have to make sure we can translate it over. You translated this percent into a decimal, and I think that's exactly right. And you
Yeah.
knew that you needed to move it over 2 times to the left, right?
Yeah.
What about that word of? What does that mean in math?
That means multiply.
That does mean multiply, exactly. And so we've changed this problem now to a math problem that people can solve, and you've already set it up there.
And
That's
I'm
a good
going to
thing
help
to do.
you guys out for a minute because she knows how to set it up, but a calculator will help with timing.
Okay.
So you can use a calculator to do it instead of doing it on the board like
Want
that.
to punch the
All right,
numbers
so
in there
here
real
you
quick?
go.
So 27.
So 27 times 0.19.
times point-
And some of the things you can think about while you're going about that process or even setting up the problem is to think about, should this answer I get be bigger than 27 or smaller than 27?
Smaller.
It should be smaller, that's right. So at least if you get an answer, it better be smaller, right? What is the answer that you got there?
5.13.
5.13, okay. And it's to 2 decimal places, which is exactly what
Yeah.
we have here. That seems reasonable. Here's another question for you, just for a matter of estimation, okay? Is 19% more than half or less than half?
It is less than half.
It is less than half. So, is 5 more than half of 27 or less than half
It's
of
less
27?
than half of
It is,
27.
yeah. Can you estimate what about half of 27 is? Just estimate.
Around 19 or 18.
A little bit less, but that's all right. Somewhere around there. So at least you know you're below that, right? You're a little below that. So just having an idea of what the answer should be before you start, always a good idea. Okay? So that's how you'd set up that one. Do we want to do another one?
Indeed we do.
Indeed we do.
All right, erase the board.
Okay.
So that one seemed pretty easy. Well,
Yeah,
you got
pretty
rid of it a
straightforward.
lot quicker for you there, Reagan. All right, Reagan, pick another 2-digit number.
37.
37. So 37 is what percent of 150?
We have another English question. And we got to make it into math, right? Have you done problems like this before?
Yes.
Good. So what are you going to do when you translate it to a math problem?
So I'm going to put 37 right here because it's the part. I'm going to
We're going to do some division.
Yeah.
Gotcha.
I'm going to put 150 on the outside.
Wow. Now, how did you know how to set it up like that? For instance, let's translate a little bit more. You told me before that of is times,
Yeah.
right? And this is the part that we don't know, right? This is like the big question mark. I'm not
Yeah.
quite sure. Of course, 150 is going to stay exactly like it is. If you were doing some algebra here, or if you were trying to put a spot there, you could put a box or a triangle, or you could put a letter there, right? What about this word is? What does that mean in math?
Division.
Not quite. How about like 1 plus 2 is 3? What does that mean?
It means the answer is
Right. In math. In math, what does is mean?
equals.
That's right. That's what we want to do, okay? So if you're translating this into math, that's kind of what it would look like. 37 equals some number times 150. And what you've done here is divide by 150 over here on this side. I like how you set that up. You want to do that by longhand? She says, no, I have a calculator in my hand. I got to use this thing. Okay, I don't blame you. Type in the 37.
I usually do this.
There you go. So at least you know what you would do if you had to do that 150 into 37, right? Oh, I like it. She's like, I can't stand to use that calculator. I got to make sure I do something here. Good. Now, where's the decimal in your answer, by the way?
The decimal is right here.
Good. I got to put that up there. So you've drawn that one. Good deal. Good so far. Doing some estimating in your head, I can tell. Good. Good, nice job. So 15 times 4 is 60, and then you added a 0. Got to bring another one down. We're getting closer.
So it's 750.
Tell me a little bit about your thinking there. What are you thinking? Like, how are you trying to get 150 into 1,000?
I'm trying to see, because I already know that 300 is
2.
2, and
Good
then
for you.
that's 4.
And 600 is 4, and 300 plus 600 is 900. We're pretty close.
Yeah, so that would be.
So what do you think it'll be?
It will be 6.
That's it. Good for you. I like how you estimated that and did a little math in your head. And you might start to see a pattern at this point.
You guys didn't want to use a calculator?
No,
right,
she's not into the calculator on this one. So you see that
So now it's gonna
you came
be-
up with 100 here, and you're going to have another 100 here. Guess
That's
what's going to
gonna
happen later?
6.
That's right. That's right. Good deal. Okay, so let's go back to the original question. What does the original question ask you for?
The percentage.
Asks you for a percent. So at the end of this problem, we have to have a percent. But you don't have a percent. You have a decimal, right? So how can you change your decimal to percent in the correct form?
You can do it by moving the decimal 2 spaces over.
I like it. Now, are you allowed, here's a trick question, are you allowed to have a decimal in a percent?
Yes.
Sure you can. You can have that, no problem. Can you have a percent in a decimal? I don't even know if that question makes sense or not. I'm with you there, 24 point.
6.
Now tell me, where are you going to round this? Because we just found out that 6 is going to go on.
24.7.
Okay, you want to round to the nearest tenths
Yeah.
place? Okay, 24.7. And that's a good percentage to have. Let's see if it makes sense. Okay? Is 37 more than half of 150 or less than half of
Less.
150? It is less, right? So it's less than 50%. That part's good. What is 10% of 150? Can you do that in your head real quick, just by moving the decimal over one place?
15.
15, right? So this is more than 10%, right? Because 37 is more than 15. And it's double, kind of double what it is. Anyway, good things to think about, so at least your answer makes sense at the end. If you get some wild and crazy answer, but you don't know what's wild and crazy, it's kind of hard to fix it. Good
There you
work
go.
there. Nice
Nicely
job.
done. Some great work on percents right there. So you can erase the board.
Okay.
And we're going to do a couple of things over here. So come on back over here, guys. I'll get the calculator out of your way. So we saw that Reagan continued working on the project here that you were working on, and we can take a look, and you've gotten a little bit farther on that, right? So you're just about finished with your homework assignment
Yeah.
on that. But remember at the beginning of the program, I said you were going to work on some nets, right? Remember
Yeah.
we were looking at the nets? So here's some shapes that you've got right here, all right? You can spread them out. First of all, tell me the different shapes that you've got there.
A rectangle, a square, a triangle, and a longer triangle.
Right, so two different types of triangles, right? And we could do a whole little segment on different types of triangles as far as side lengths and measurements and things like that, but we'll do something else. So are you able to use these shapes and make a cube for me?
Yes.
So what I want is
She says, watch me go.
I
Here we
want a net of a
Okay.
cube. So I just want the cube laid out as a net.
Okay.
And then once you do that, put it together somehow and see if it actually makes the cube. Make
Okay.
sense? All right,
Yes.
go for it.
So if somebody squashed a cube, well, what would it look like? We're going to see if we can connect them too. Okay, so there's 2 of them there. Now, do you already have an idea in mind when you're going about these?
Yes.
Okay.
And maybe if you keep
what
it
is that
on the
idea?
on the
Yeah, you can just squish
snap
them right in
them
there.
together like that might be a little bit easier.
Snap them in sideways, or you can get one edge up and squish it down on the other side.
I am.
Yeah, you can do it that way. There you go. Good.
Feel it and hear it snap into place.
That's right, and then you know what you're doing. So you have an idea about what you're going to do first. What is that idea as you do it, so we can kind of understand your thinking?
I'm going to put 1 square on each side, but on one of them, I'm going to put 2 for the top.
Oh, okay, for like the lid. All right. So maybe if you think about this and you're putting it all together, if you folded it up right now, it would be kind of be like a box with no lid, right?
Yeah.
Yeah, okay. So you really are kind of thinking ahead about how that's going to look.
There we go.
Okay, so that's the net that you want to have, and you're pretty confident that'll make a cube,
Yes.
Would
Okay.
you be willing to bet on it? You are.
huh? How confident?
All right, you sound pretty confident in that. All right, fold it up. Let's see if you can make a cube out of that.
And there's a lid, with the all-important lid there.
There you go,
Nice
nicely
job.
done. Look at that. They even gave you a round of applause on that right there. Okay, so the next thing I would like you to do is make a net for a triangular pyramid.
Okay.
You think you can do that? Okay, we'll put this, do you need any of these pieces to make a triangular pyramid?
I have some here.
Okay, so you don't need any of these squares. That's the first step. That's a good choice right there. Okay, so take a look at what you've got left, and because you've got two different types of triangles there, and you want to make sure that you are using the right ones to make a triangular pyramid. Have any idea which ones might be better to use?
I'm pretty
Want to
sure.
try those ones?
Yeah.
All right, go ahead.
Does it have to have a bottom or no?
Well, in order for it to be a pyramid and a triangular one, it's going to need the bottom, and the bottom needs to be what shape?
A square.
Well, then
He
it would
said
be
triangular
Wait, no,
pyramid,
triangle.
right? There you go. Got to have a triangle on the
That's
bottom.
right.
There you go. Yeah. Good. And all the sides, what shape are they?
Triangles.
They're triangles as well. So you have a bottom that's a triangle and also some sides that are triangles. There you go.
There we go.
Tempted to get one of those big ones, I know. Okay.
So you think
Any
that's
more?
it, or do you need more?
Don't you need a
That's
roof
it.
like you did on a cube?
No.
How come?
These corners, the tops will match together and create a top.
You won't need a roof on that one because there's no roof. It just comes to a point, right? So good thinking about what's going on in your head to have an idea what's happening before you put it together. Can you make us a triangular
Yep.
pyramid? Good, there you go. Nice job.
All right. So, what is the difference between a pyramid and a prism? Do you know?
Prisms are round. Like they're like smooth.
Like a cylinder?
Yeah.
Is that what you're thinking? Okay.
Yeah, they're like that.
How about if Scott helps you? And what I'd like you to do is I'd like you to make a rectangular prism. See if you can do it with the shapes that you've got there.
Okay, so
So what in your mind, can you think of an everyday object that looks like a rectangular prism?
like a box.
Box, yeah.
So would this
Is that a rectangular prism?
count as a prism?
Not sure.
Well, here's a question. Is
With
this
this?
a pyramid?
What?
Is this a pyramid? Not a pyramid, right? So we have a three-dimensional shape that's not a pyramid. It's likely a prism, right? And does it have a rectangle on the bottom?
No.
Is a
Oh,
square
yeah.
a rectangle? Yeah,
Yes.
square is a rectangle. And on the top? And then the other side is just going to fold up, right? So
Yeah.
same type of deal. It just happens if you're a very specific rectangular prism, happens
Yeah.
to be a cube, right? So I think you're already thinking a little bit to yourself, what kind of shape can I make? A rectangular prism, got to have a rectangle on the bottom and the top,
Yeah.
and you can fill in the rest of the sides, right? Okay, so what other pieces do you think you might need?
These rectangles.
Okay,
And I'm gonna take off.
good. So if
another
you
one.
wrapped all those together, right?
Yeah.
Then they would make kind of a tunnel, but then you're going to need some ends. And the ends now are squares, and that makes a
Yeah.
really interesting thing too. How did you decide to have a square on the end?
Because
Like, why wouldn't it be everything be rectangles? Because on this one, everything was squares.
It wouldn't be that because you would the sides would end up being smaller.
Oh, gotcha. Yeah, it has to do with the length of this side here, right? You got to
Yeah.
be able to cap those ends. Good for you. I like the way you're thinking there. There's the snap we were looking for. Okay, so that's the net you want? Okay. And the moment of truth with the lid and the side. And this is where all that practice with Legos when you're getting younger comes into effect, right?
Yeah.
Make sure all the pieces go together. Good for you. Nice job.
All right, so you've got one more, but you've got these pieces. What do you think you can make out of that?
Okay. Like a long triangle.
A long triangle.
Kind of.
It's good thinking.
You have to use all of those pieces. What can you make out of that?
Like, forgot the name of it.
So start putting them together, see what you can make. I'll give you about 4 minutes to see what you can do. And it's not a race. I mean, if you can do it in quicker time, that's fine. But you need to be able to explain what it is also. So you need to classify it.
I think you just made a star. It's a pretty nice looking star, though. Oh, so your net's done already. So you already made your net, and in your mind, did you know that this shape was going to come to a point at the top?
Yes,
Okay. How did you know that?
because they are all triangles.
Ah, that's going to make a difference, right? Definitely. You had all triangles in the other one. And by the way, what do we call this shape over here that had all triangles?
A triangular prism.
Wasn't a prism. A little bit different.
Triangle.
Like in Egypt?
Pyramid.
Pyramid, right? So tell me why this one is called a triangular pyramid. We know it comes to a point, but why is it called triangular?
Because all of these sides are triangles.
Yeah, all those sides are triangles too. What's the difference between this one and this one that you made?
That one includes all triangles and has a triangle at the bottom.
At the bottom. So the base is what tells you about the pyramid, right?
Yeah.
In this specific instance, we have a triangle on the bottom, makes a triangular pyramid, comes to a point, right? What do you think you would call the one that you just made? First of all, is it a prism or is it a pyramid?
Prism. It's a triangle. You know,
So remember, this comes to a point. Does this come to a point?
yes.
So we have a pyramid, right? Just like in Egypt.
Yeah.
What kind of pyramid do you have?
A
Look at the base. That's exactly right. Turn it upside down. What is that base on the bottom? What would you call that?
square.
Square. So you could call it
A square.
a square
Pyramid.
pyramid, right?
Yeah.
What's another thing? You just told me a little bit about squares. What are they also defined as or classified as?
rectangular.
A rectangle,
So
right?
a rectangular prism.
Rectangular
Pyramid.
pyramid. There you go. So all those vocabulary words come back, and it's hard to keep them straight, but you did a good job of that because it's
Yeah.
kind of hard to figure out. You knew what you were saying, you knew what you were doing,
Yeah.
but getting the right words there is really important when you're trying to describe it to somebody. Imagine trying to describe somebody over the phone what you just made. That's a good lesson in directions, I'll tell you that right there.
Nicely done, you guys. Now, have you worked on anything like surface area of 3D objects yet?
I'm not sure.
Okay, well that means you probably haven't. Okay, and if you had, maybe you hadn't done it enough where it comes easily to
Yeah,
you.
I may have done it in 5th grade.
So what I'd like you to do is take any one of these apart. Just have it lay out as a net again. Any one you want. I think the trick is getting the first one loose, and then the other
Yeah.
ones will be a little bit easier after that.
Good, there you go. So you're back
So
to a net.
if it's laid out like a net, do you think it would be easier to find the surface area of this as opposed to doing it like this?
Yes.
Okay, that's exactly why we wanted you to do that. And so that you get familiar with what a net is, how you make a net, and then how you can turn it into a 3D object also. Make sense? Yeah. All right, so that I know it's going to come later on in 6th grade for you. But we do have one more opportunity to head back out to Meadows Field and check in with our aviation correspondent, Diane.
Thank you, Mike. We're back here to show you one more biplane. It's a little bit different than the rest. I'm here with my friend Doug and his Pitts Special. Is that what this is?
Yeah, it's the Pitts S1S or the Pitts Special. Yeah, so it's purpose-built for aerobatics, otherwise known as stunt flying. So it was originally, the original version of the Pitts S1 was built all the way back in 1945, and they're still being produced to this day. So really significant little biplane and really reinvented what modern aerobatics looked like.
So not a race plane then, it's
No.
aerobatics.
Some people do race theirs, but this one in particular, this is made for flipping over, doing all sorts of fun stuff.
So what makes it suitable for aerobatics then?
Yeah, so the suitability for aerobatics of this airplane in particular is both wings have a very symmetric airfoil, meaning that the shape of it really is more even on the top and the bottom, meaning that it can fly really well upside down and fly really well right side up. It has 4 ailerons, which means it rolls very quickly as well.
So the steerman is covered in fabric. Is your airplane like that, or is it covered in aluminum?
It's ironically, it's extremely similar to the Stearman, where it
Really?
has a wood structure inside of a fabric-covered wing and then a tube structure for the fuselage with fabric covering.
So the Stearman can do aerobatics too, but it's not really a hardcore aerobatics plane because you know, you need to maintain positive forces or the engine will quit on you. It loses fuel, it loses oil. Can yours, you know, maintain fuel, oil, all that good stuff?
It sure can, yeah. So the firewall forward of this airplane, there's a whole lot special going on in there. So inside there's a ball, a check valve, and an air oil separator to make sure that you can get good clean oil being returned from the engine back into the sump the whole time. It'll be able to make oil pressure in any azimuth. And inside of the fuel tank, you have what we call a flop tube. So it's a little tube that goes back and forth to try and suck gas down into the engine, and a fuel pump to keep positive pressure on the whole time.
All right, well, can you show me the engine a little bit?
Sure.
Let's just point it out. So like this engine looks a lot different than, you know, the Stearman is a big round engine and cylinders hanging out there, and the AN2 is a big round engine. It's covered in a cowl.
Yeah.
But yours is not round, really.
Yeah, not at all. So it is quite the opposite. It's horizontally opposed, which means that it has 4 cylinders, 2 on each side of the crankcase, and they go in opposite directions. So the pistons kind of work themselves back and forth like this. So still air-cooled, but the challenges are very different in the way that the whole sort of front of the airplane is shaped, which is why it looks so different. Just those 2 little holes to let air in the front, keep it nice and streamlined, versus having all of your cylinders out into the free stream or out into the air just to get the cooling.
Right, so how much power does this make?
So it only makes 160 horsepower.
Oh my goodness.
Yeah.
All right, that's almost half of the Stearman and a much tinier fraction of what the AN2 does.
Very much so.
So how fast does it go then with only 160 horsepower?
Well, so the red line's up at about 200 miles an hour, and you may not be able to find it level, but we certainly find it on the way down into an aerobatic box.
So red line?
Red line's the fastest airspeed that the airplane's allowed to fly.
Okay, so this is actually way faster than the other two, even though it has a whole lot less power.
That's right.
So
a lot of that attributed to the fact that it weighs almost a third of the Stearman and a tenth of the AN2.
oh my gosh.
Yeah.
That's what, 1,100 pounds? is it?
1,100 pounds, yeah. So
My goodness, what a difference.
yeah, about a fifth of a normal truck. Yeah.
So what else is special about it for aerobatics? I know we've got some things hanging off the side that I don't see on the other 2 airplanes.
Yeah.
Can you tell me what I'm looking at over here?
Yeah, so we have the aerobatic sight here. This allows you to fly the airplane good, straight, and level down the middle. You can fly the airplane perfectly vertical by using this little guy here, or you can fly vertical 45 or down 45 lines by using these 2 pieces right here. So you line them up with the horizon and you're flying straight down at a 45, level, or vertical.
So with you sitting in the cockpit, you look out to the side and then you see the horizon to tell what you're doing. So it's not an instrument inside the airplane that's telling you that. It's actually just this piece of metal hanging off the side of the airplane that's telling you that.
It's certainly not, yeah. And so when you're flying upside down and doing aerobatics, your head is very busy. You're not looking inside the cockpit. You're really looking all over and getting reference to the world around you, which is why this lives outside on the outside of the airplane.
So can we get a look at inside the cockpit?
Certainly can. So a fair amount smaller than the others, that's for sure, but still has the standard stick in your right hand, throttle in your left, just like the Stearman, 2 rudder pedals down at the bottom with brakes on them. So it looks a whole lot like most other airplanes, but what you can get out of it is a fair amount more.
Oh, hey, what is this a parachute you have in here?
It certainly is, yeah.
You've got a parachute in it.
Yeah, so if you're going to flip your airplane upside down and go in all sorts of azimuths, it's a good idea to be able to get out if something goes wrong.
So is that all these extra straps we have in here?
Yeah, so in this case, the straps are there specifically to keep you as attached to the airplane as you can possibly be, right? So when you flip the airplane upside over, right, you take the acceleration of gravity, and now instead of pushing you down into your seat, it's trying to pull you out of it. Well, it's a really bad look when you flip the airplane upside down and your head goes into the canopy. So in this case, there's actually an entire ratchet strap there to hold you really tight down into your seat. And I'm not a small guy, so it's a pretty strong strap.
How cool is that?
Yeah.
Well, thank you so much for showing us your Pitts biplane today.
Of course.
And talking about it.
My pleasure.
So I think that's all we have for you today. Todd, if you would come on over. Thank you so much
you're
for
welcome.
having this gorgeous museum piece to show us today. Is there a way that members of the public can see your airplane?
Yeah, we're on Facebook, Golden Age Flight Museum, and also Instagram and the website, goldenageflightmuseum.org. And there's all sorts of good videos and pictures of all the airplanes flying and nice write-ups about the history of them.
And all sorts of cool airplanes in addition to the AN2, so there's
We
more
have a
out
lot
there
of
than that.
airplanes.
Well, thank you so much, Todd, for your
Thanks.
time, and thank you so much, Doug,
quite
for
welcome.
your time as well.
You're quite welcome.
And Mike, back to you.
All right, thanks for that, Diane, and welcome once again to Diane, our aviation correspondent, part of our Do the Math team here in our 21st season. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. And Reagan, a 6th grade student from Buena Vista, has been doing some excellent work so far today. And for her great efforts, she's got herself a meal courtesy of our friends at the Broken Yolk Cafe. So congratulations on that. And you've been there, correct?
Yeah.
Do you have a favorite meal there? Do you go for breakfast or lunch usually?
Breakfast.
Breakfast, that's when the old man goes there too. I'll tell you, boy, you get some flapjacks, hot pit. That stuff's good. All right, so anyway, you've been working on your project here.
Yes.
And let's take a look, because you filled in the 10 by 10.
Yes.
You made smaller rectangles and squares to fill it in. All right, and how are you feeling about that right
Good.
now?
Feeling pretty good?
Yeah.
If you had to, could you make some more?
Yes.
Where? It's all filled up. Where would you make them?
I can make them in here.
You could cut some of the other ones into different
Yeah.
pieces, right? You can even make some smaller pieces inside other pieces.
Yeah.
But you're feeling pretty good about this one?
Yes.
Okay. We want to make sure that the math works out real quick, okay? So let's just see. Remember earlier, you measured out this side over here, right?
Yeah.
And you put a little tiny number over there. Do you remember how far it was?
3 inches.
3, that's it. So this is 3, okay? And go ahead and let's get your pencil. Put a little small number into what this one is. What's that one?
1.
1, and what's the last one?
It is 6.
Are you sure?
Yes.
Okay, measure it out real quick just to make sure. Because if we goofed up, we want to fix it before the whole thing gets done, right?
There we go.
Especially before you get that pen on there. So there's 6. Good. So we know that full side is 10, and of course it's supposed to be 10. What about this one here? Can you measure out these individual pieces here just to make sure that you
Yes.
are right on?
This is 3.
There's a 3.
This one is 2.
Yeah, 3 and 2 is what? What's
This-
3 and 2?
3 and 2 is 5.
5, so we're halfway there.
This is 1.
That's 1, yeah.
This
And the last one?
4.
Good. So 3, 2, 1, and 4. Does that add up to 10?
Yep.
It does, and you could do the same thing on this side and the same thing on this side, and of course you get back to 10, you can see you filled up all the spots.
Yeah.
What will you do when lines don't hit exactly where they're supposed to be? It's pencil, you could fix it, right?
Yeah.
It happens sometimes. And because you could have little tiny fractions of an inch here if you wanted to.
Yeah.
The other thing you could do is make really thick lines when you go and use that Sharpie, huh?
Yeah.
Then we can kind of fix that up a little bit as well. But I like how you did some exact measurements, at least at the beginning, right, to make sure that your squares and rectangles were pretty close, the best you could do anyway, to get into exact numbers, to
Yeah.
even numbers, because those fractions, while they are necessary, they're not always the most fun thing to do.
And one thing I'd like you guys to do is, because you did an excellent job on this, is just take, I'm going to pick one randomly out of the middle,
Okay.
and just measure it to see if it is actually whole numbers that it measures out to be.
Okay.
All right. So let's do this one right here. So can you measure 2 of those sides to see if those are indeed whole numbers?
That is 2.
That is 2.
And that is 3.
Hey, well done. Look at that. It did work out pretty darn well.
Yeah.
Nice job.
So if it's a 10 by 10, and you have all of those different shapes in there, when you find out the area, so you said this was a 2 by 3, correct?
Yeah.
So what would the area of that one piece be?
That would be 6.
Okay, so that would be 6. What would the whole thing be when you add all of them together? What should it be?
It should end up being 100, yeah.
Right, it should be 100 square inches, correct?
Yeah.
So that's how you can check your work to make sure, right? You can do the area of each one of these, see what they are, and if they all add up to 100, then you've done your math correctly, right?
Yeah.
Does that make sense? All right, so the next step you have to do with that is what?
I have to color it in.
Well, before you
Well, I
color
have
it in,
to-
don't you have to outline the lines?
Yeah, I have to outline the lines.
All right, so we're going to let you do that, but I have a couple questions for you. Did you learn a little something today?
Yeah.
All right, good. Now, the more important question, did you have fun today?
Yes.
All right, good. Well, you know what? We thank you for coming in. All the best to you in your swimming and the 200 fly. And maybe we'll get Scott in training, and maybe you guys can go out to the pool and do a little race right there. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.